Hello everyone. In this video I want to show you two I would call mid-level advanced techniques for creating springs. For the springs that we have made in previous videos on the SolidWorks playlist, the spring was cylindrical like this, and the pitch was constant, the distance between these coils. And we could at best really the videos that I showed you taper it outward or inward. So what I want to show you today is what if the profile of the spring is like this. You might call it a ball spring, or a kind of maybe it's not really, but kind of like a spherical spring. Okay, and for which the profile or the helix that is kind of basically expanding and then shrinking. For that, such curve does not exist. You cannot make it with the helix command. And then this one that has a variable pitch that, like here in the beginning and at the end, toward the sitting areas, it has a smaller pitch, and in the middle it has bigger pitch. And this is what you probably see in real life for most of the springs. So how would you make stuff like this in SolidWorks? So for the first one on the left, for this one, what you need to do is called a variable pitch. So let's go ahead and make a variable pitch. So you go here under the curves, the helix one, under the curves but helix, select this top plane and then draw a cross section. Here dimensions don't matter, you can just type in anything that you want. Okay, because my goal here is really show you the process, not make something that matches one on the shelf. So you see, this is the constant pitch that we did, and you can make it taper, but there is this variable pitch, and I go with pitch and revolution for definition. And so here, let's say I want to have 10 revolutions. I say in revolution 0, I want my pitch to be maybe an inch. And then in revolution 1, I also wanted it to be an inch. So between 0 and 1 doesn't basically change. Then when I go from 1 to 2, I want it to increase to 2. And then from 2 to 8, I wanted it to stay at 2. And then as we go toward 9, I want it to start shrinking. And finally, when we go to 10, I wanted it to between 9 and 10 to stay at 1. Something like that. If you look, you see? Right? So clearly you see that the pitch is what? The pitch is variable. This guy is quite a bit tall and narrow, so it's quite flimsy. It can buckle easily. So let me bump up the diameter a little bit. Okay, now the interesting part is, you see, when you create a helix, if later you go back and change the diameter of the base, the rest of the helix does not get updated, right? Even if you update it, you see nothing happens. And this definition of helix is basically has no room to change that diameter, because you see here, once you do this variable pitch, then here it has its own diameters for each section. So if you want to do that, you have to come here and change it. Okay? And that is another thing you have to keep in mind when you have variable pitch. Then at each section you have a separate value for diameter. Okay, so let's say we have this one. And now, of course, I can go here with a circular profile and with this helix as the guide, and with an appropriate thickness for the spool, I can make a spring like this, which clearly you can see that it has the variable pitch. And in real life, we don't leave the springs like this. Typically, these surfaces are going to sit against something, so we need some flat area here. Therefore, we need to do some cuts. Okay, and again here, I don't go with exact dimensions or something. I just want to create some flat surface at the top and then the bottom. And so here I do just some cuts, and I make it through all in both directions like this, and there we go. So now I have this flat surface here for sitting, and I have this flat surface for for sitting too. So this is actually, I would say this is more realistic compared to something that has constant pitch all over and no sitting area. The next thing is the other one, which has this profile. So as I said, the helix that has this diverging converging cross section, there is no such an option in the helix command. So you need to make the guide curve here using a different technique, and we can use a surface design. So here I go to this front plane, and then I use a 3-point arc like this. And let's say make sure these two are vertical, and then these two are horizontal, and then provide some dimensions here. So this span here, let's say 4, then this offset here, let's say half, then you need some radius here, let's say 2.5. Okay, so something like this, and then you need to rotate it about an axis. So let's make that axis in a separate sketch, which is passing through a vertical line passing through origin, something like that, extending beyond this guy in both directions vertically. And now I can use my revolve surface and rotate this about that axis and make the first surface. And then I need to go to the front plane, and I need to create a second surface, which I start from the top of this line and go horizontally and make sure it extends beyond the boundaries of this surface. Okay, so it extends to the right of that. And then I go ahead and use a sweep and sweep that line along this line. You might say, well, you just get a plane. That's right. But here what I want to do is to give it some twist. So I go to options, and then here for profile twist, I say I want to specify the twist value, and I want to say how many revolutions, and then I start twisting, and look, you get a surface like the surface of a worm gear. Okay, so you get this twisted surface, and now look, you have this beautiful surface. Now if I go to sketch and under the projecting dimensions, right, convert entities, if I go and use intersection curve and I do the intersection of these two, I will get the curve that I want in black, as you can see. So now that the sketch is made, it's a 3D sketch. I can hide these two surfaces. I don't need them anymore. That's the profile. And of course, I can go ahead and use a sweep with a circular profile on this, and I can get the spring that I want, like that. There we go. Okay, so hopefully this video was useful to you, and I'll see you in the next lecture. Thank you.